This set of videos is on exact equations. So it's a rather convoluted way to solve a differential equation, but it actually occurs fairly often because of physics. A lot of physics equations are differential equations, and they have to do with conserved quantities. So that's where they come from mostly. But here's the definition. So a differential equation created by taking a derivative of an equation in the form some function capital F of x comma y is equal to some constant c. So here's an example. We have 14x y cubed minus e to the x plus 21x squared y squared plus cosine y all times y prime equals 0 is an exact equation. And I'll show you that it is by essentially showing you f and taking the derivative with respect to x. And so if I have this equation, 7x squared y cubed plus sine of y minus e to the x equals 73, let's say. If I take the derivative with respect to x on both sides, and knowing that y is a function of x, so here just 7x squared y cubed plus sine of y minus e to the x equals d dx of 73, what we'll end up with is, right, so the first term, we're going to have the product rule. So I'm going to do the x squared first. So I end up with 7, the 2 drops down, becomes a 14. And then the x squared turns into x, and y cubed is left alone. And the other half of that product rule, I'm going to focus on the y cubed. So that's going to, a 3 is going to drop down, and we're going to have 3 times 7, which is 21. X squared is not part of this, part of the product rules, so we're going to leave that alone. Y cubed turns into y squared, and then because y is a function of x, we also need y prime. In the next term, we have a derivative of positive sine of y is positive cosine of y, but we also have to, using the chain rule, you have to have a y prime pop out. And then the next bit here, we have minus e to the x. Take the derivative with respect to x. That's just minus e to the x again. Then the derivative of 73 is 0. And so the terms have been rearranged a little bit, but here's our 14xy cubed. There's the 14xy cubed. Here's the minus e to the x. Here's the minus e to the x. Both these terms have been grouped with a y prime, so we have a 21x squared y prime. There's the 21x squared y prime. And then here's the cosine y prime. So that means that this differential equation was an exact equation because you could essentially make it by taking the derivative of this equation here, the 7x squared y cubed plus sine y minus e to the x equals 73. And so the idea here then is, okay, well, if this equation exists, this f of x comma y, maybe we can work backwards from the differential equation we have to actually get there and get rid of the y primes, and we actually have an implicit solution at least. And so we're going to continue on with that in the next video.